So now we'll discuss question of day 7. That is the first question from day 7. Rotate list. So what is given in the question? We are given the head of the linked list and we have to rotate the list to k to the right by k place. So we are given the value of k and the head of the linked list. So for this particular question, the value of k is 2. So this is the given linked list. If we rotate it by k, what will be the output? Let k is 2. So if we rotate 1, this last node will come at front. And if we rotate one more time, this last node again will come to the front. So this will become our linked list. So this is the question. So what will be the approach to solve this question? So how will we approach this question? So this is the given linked list. So our given value of k for this question is 2. So we have to rotate the linked list from the right 2 times. So at the first time this will be the result, the second time this will be the result. So we can observe the output. So this will be our answer at the end. So if we have to rotate the original linked list k times from right, what we can see, we are just moving the kth node from the end to the head, to the head, kth node from the end to the head. And what we are doing, we are just making this node as the tail of the answer node, and this node will become head, and this act as a link between the new. Okay, so it would be better understood when I run this test case. So what we have to do, we have to find the kth node from the end. So kth node from the end, that will be this node, this node. And we also find the tail of the linked list. We find this node, that is the new head node. What we'll do, we'll make this points to this, we break this link, and we'll return this head. So now what will be our linked list? 4, 5, 1, 2, 3. So this is the simple. It just a matter of observation. If you observe this thing, it would be a cakewalk for you to write it. So I will explain you how will we do the things. So the first step, what we have to do, we have to find the kth node from the end. This question we have done previously. So what we'll do, we'll maintain a pointer that will initially be pointed to kth node from the front. So this will be a slow pointer, and a fast pointer will be pointing to the head of the node. And we'll move these both pointers one step at a time, and will iterate over the linked list. So at the next iteration, fast will be pointing to this node, slow will be pointing to this node. At the next iteration, fast will be pointing to this node, slow will be pointing to this node. Okay. At the next iteration, what will be the case? What will be the case? Fast will be pointing to this node, and slow will be pointing to this node. So we'll iterate over the array till the slow pointer reaches the end, or until the slow of next become equals to null. Okay, we'll iterate over the linked list. Now this fast pointer would be pointing to the kth node from the end. Okay, from the end. We also maintain one more pointer. That pointer is just keeping the count of the previous node, k minus 1th node. Let us suppose we name it as previous. So what will be a scenario in the present case? We have 3 pointers the present case, we have the 3 pointers. Slow would be pointing to our tail, fast would be pointing to the kth node from the end, and the previous would be pointing to this node. So now what we have to do, we have to set up a link between the slow and the original head. We set up this link. We simply do slow of next equals to head. We set up this link. Now what we'll do? Now what we'll do? We'll make this is the new head. This is our new head. So what we'll do? We'll make. We have set up this link. We have set up this link. Now it had become a circular linked list. Circular linked list. Now what we'll do? We'll make the head points to fast. Now our head become this. Okay, head become this. We'll break this link. We'll break this link and just return the head. It is as simple as that. Previous का next null कर दो, ये link break हो जाएगा, fast पे head खुल जाएगा. It is as simple as that. So we have to just find the kth node from the end. तो हमें उससे क्या मिल जाएगा? Tail pointer. First thing. Second thing, the kth node from the end. That will be our new head, and we maintain a pointer to k minus 1th node and make it point to null. So that node, let it be previous, it would be pointing to null. So its next would be pointing to null. Okay. So this is the case. Let me show you the code for this. This is a very simple question of the linked list. Okay. Linked list is a very simple topic if you apply a little bit of your mind. Okay. So now we look at the code. So this is the function rotate right that returns the list node pointer, and it has received two parameters, that is the head of the linked list and the value k. The first thing is the parameter check. If the linked list is null, what we will rotate? We'll rotate nothing. We'll return null. If there is one node in the linked list or the value of k is 0, we have to return the head, because we do not have to rotate the linked list any number of times. We do not have to rotate anything. And if there is one element, the rotated version will be same as the original linked list. So we'll return the head of the linked list. Then what we will do? One point which I missed during explanation is that if the value of k is more than the length, we have to take the modulus. So for that, we have to calculate the length of the linked list. And by doing it, we also get the tail pointer that will be pointing to the end of the list. Okay. So what we are doing, we are maintaining a temp pointer that initially will be pointing to the head of the linked list, a tail pointer that initially would be null. Our length initially would be 0. We'll iterate over the linked list until we reach the end of the linked list. Our tail pointer would be pointing to the end of the list, and we have calculated the length. Okay. Now we'll take the modulus k modulus length that will give us the value of k, updated value of k, because in the case when we have to rotate the linked list k number of times and k become equals to length, so length modulus length becomes 0, so we don't have to rotate it any number of times, so our work will be reduced. So this is what we are doing. If k equals to 0, it becomes, we'll return the head. Or what the next what we have to do, we have maintained a temporary variable p. We are storing the value of k minus 1. Why we are storing the value of k minus 1? Because we have to just move a slow pointer to the kth pointer from the front. This slow pointer will be moved to the kth place from the front. the slope pointer would be pointing to the kth position from the kth node from the front. Okay. Now what we are doing, we are taking two pointers, the first and the previous pointer, and we are using the loop until the slow pointer would be pointing to the last node, and we are also maintaining a previous pointer. We have discussed earlier what the previous pointer will be pointing. It would be pointing to k minus 1th node. Okay, so we are also maintaining the previous pointer, fast pointer, and a slow pointer. Until the slow pointer points to the end node, we are moving ahead in the linked list. Okay, by and moving the fast and the slow pointer one step. Okay, so next, if the when the slow pointer would be pointing to the end of the linked list and fast pointer would be pointing to k minus kth node, what we are doing, we we already get the tail. We can also use slow pointer, but we have already get the tail of next. We are setting up the link between the last node and the first head node. Okay, we have set up the link. We have make the kth node as the new head, and our tail would be pointing to the new tail, that is the previous node, and make the previous of next, that is the new tail of next, as null, and we'll return the new head of the rotated linked list. So this is the approach. How will we solve this question? So if you have any doubt, please feel free to ask in the comments. Bye.